I'm John Anderson. Today I'm going to show you how I made these rock solid, tightly wound, tightly cast wind turbine coils with nearly flawless perfect alignment. I've read dozens of websites and quite a few books about how to make wind turbines, and none come close to the perfection I have attained here. But it does take time. I'm going to show you the jig, then I'm going to show you how to use it effectively, how to build it, and then show you the difference between my coils and normal DIY coils like this one, which I'll come back to a bit later. And if I have some time later, I shall explain coil sizes to magnet size ratios, all of which are quite difficult information to find on the net. Most wind turbine books, it's quite difficult to find that kind of information too, about coil thicknesses compared to the magnet sizes, etc. I'm not going to show you how to make the stator or anything like that. That information is widely available on the internet. Cut and paste these links to your browser. Okay, I'm going to do this in two parts, so don't forget to watch part 2 and take it from there. Alright, I've made this from strong steel because wooden ones break easily when applying as much force as I do. When I'm winding my coils, I really apply a lot of force when I'm pulling it through this feeder here. The counter is a very important thing. I doubt you'll find one like this, but if you can use a mileometer from a scrapped car or an electric sports stepometer or whatever, do not try counting in your head, because I promise you will lose count. And you might get a phone call, or it might be somebody at the door, whatever, to make you lose count. And all of your coils, whatever size or however many turns you decide to use with, must all be exactly the same. There's no exceptions. That's why you must have some kind of countometer. I always wind my coils clockwise, and I always start here and finish here, as quoted by Hugh Piggott, among many others. Okay, I've used bearings with a wooden platform, and this is for the copper wire. It's very important this goes around freely to avoid any kinks in your wire. What I mean by kinks in your wire is if it goes around like this and gets trapped like that, that's going to be a kink. You can't use that. You're going to have to start all over again if you get any kinks or twists or wiggly bends in your wire. Just don't use it. This design eliminates that. It will go around. It eliminates all possibility of kinks and twists. Next is the part which aligns the wire to the coil that you're winding. This must be plastic or wood to avoid scratching the enamel or the insulation on your wire. You can put 2 or 3 wires at the same time through this. Just put 2 or 3 coils on this feeder part. The alignment of this part is very, very important. I've drawn this orange line to show you that what I mean by alignment. If you're looking with one eye closed and you're looking at the line of the wire, they must be perfectly straight when it's got tension, tight tension. If it's not, then just adjust your nuts left or right to attain the perfection. Also, you must measure point from here. The point must be X amount of centimeters to here must be exactly the same X amount of centimeters. Adjust this reel up or down. It's got a little grub screw inside. You can use this Allen key to adjust it up or down. That's a good thing I like about this little plastic thing. That's how you attain the alignment. That's very important points I'm explaining to you now, so listen up. Once you have the alignment, I will hand feed the coil the first 6 or 7 windings. And then I will add 1 or 2 drops of this liquidy super glue. It has to be quite runny, liquidy super glue. This is really strong stuff. Right in the centre of the wires, without touching the solid plastic sides of the mould, left and right. I use hard plastic because it's much stronger than wood and it doesn't leave indents from the spacers. You can use some oil or grease on the surfaces so the glue doesn't stick to the wire. I have glued a few coils already to these moulds accidentally. That's why I emphasise only use 1 or 2 teardrops carefully in the centre of the windings. I'm working with 70 turns for each of the coils I'm doing just now. So the first 20 winds I would use 2 drops only. 1 drop there, 1 drop there. Then maybe 4 drops on the finished product after I've got all 70 turns. It must be high strength super glue, which is quite runny. I've tried thick glue before and it just doesn't work. I've tried it, it puts a space between the windings. Runny glue, however, seeps right into the spaces between the windings. Then I will leave it for 24 hours, come back the next day, and voila. Like I said, perfection takes time. It only takes 2 or 3 minutes to wind your coils, but once you attain the alignment I was talking about, you can see the difference. I will show you in a minute. These coils have 70 turns each. They're almost identical. One I did with this super glue, this super runny glue, wherever I put it, here, which was this one. You can see the glue on the edge, and the other one without. And instantly anybody can feel the difference. This one is without the glue. It's lost its consistency as soon as you take it off of the jig. You can feel with your fingers it's wiggly. Also, whilst taking it out of the jig, all that time spent attaining the alignment was wasted. I can wiggle it back and forth with my fingers and it's all puffed up. The glued one, however, remains as tight and as solid the same time as retaining its alignment, just as I had done it. The technique using this jig is ideal for almost all types of coils, like bedini coils or other types of power coils, not just wind turbine coils. It's a jig for life. And with this, you're going to avoid all kinks. As I'm winding it through, I put quite a lot of tension on it. When I'm winding it, I'm holding this area. God, this camera's not very good, sorry. God, I'm totally useless with this camera in my hand at the same time. I'm pulling on it here as hard as I can with this hand, my left hand, and winding it through. So as it goes round, this comes round, and like I said, all possibilities of any kinks are eliminated. Okay, next I'm going to show you how to make it. Trip to your local scrapyard, find the metal you're looking for. This looks ideal. This is about maybe between 5 and 10 millimeters thick. The thicker the better. Try to look for larger parts than you intend to work with, as you will cut them later to size later. You will find hard plastics in a scrapyard as well, nuts and bolts as well. If you look careful enough, you might find something else that triggers your imagination. Okay, back to the workshop. Okay, here's some examples of what I found off of the scrap heap. Some really good stuff here, solid, rock solid metals. I must assume that you have all these kind of tools to work with, otherwise you're going to have a hard time building yourself a wind turbine. I've only got a couple of minutes before my 10 minutes time is up, so I'm going to jump to part 2 fairly soon, so don't miss out on part 2. Allow me to apologise for my bad quality camera phone. It's really difficult to use with one hand. I'm going to have to figure out something else to work with it. So I'm going to go to part 2 now, and I'll explain some of the things I found and how to use them. See you there.